Today in Science from Wired.
This episode is brought to you by ShipStation. You know, folks, I'm all about working smarter, not harder. Running a successful e-commerce business can be really convoluted, and honestly, you have enough going on, so I want to introduce you guys to ShipStation. I love using ShipStation because it makes it so much easier to automate all my shipping tasks, and I can manage all my orders in one simple dashboard. Work less and ship more with ShipStation, the innovative tool that helps turn your shipping challenges into opportunities for growth. Go to ShipStation.com and use code TechNews to sign up for your free 60-day trial. That's ShipStation.com, code TechNews.
Today we ask, what do we owe the octopus? Mounting research suggests that cephalopods experience pain. Now the National Institutes of Health is considering new animal welfare rules that would put them in the same category as monkeys. Consider the octopus. Smart and sophisticated, it has a brain larger than that of any other invertebrate. With 500 million or so neurons, its nervous system is more typical of animals with a backbone. In lab experiments, the octopus can solve mazes, open jars, and complete tricky tasks to get food rewards. In the wild, they've been observed using tools, a benchmark of higher cognition. Researchers have long been awed by their ability to camouflage, regenerate lost limbs, and release ink as a defense mechanism. They have been used for studies on how psychedelics affect brains, and they may even dream. Importantly, research shows that they also seem to experience pain. Almost all animals have a reflex for responding to noxious stimuli, called nociception, but not all are aware that the sensation is bad or unpleasant. An awareness scientists now think octopuses and other cephalopods have. Some scientists say this is proof of sentience, the capacity to experience feelings and sensations. The state of cephalopod science has prompted the United States National Institutes of Health to consider whether these animals, which also include squid, cuttlefish, and nautiluses, deserve the same research protections as vertebrates. A growing body of evidence demonstrates that cephalopods possess many of the requisite biological mechanisms for the perception of pain, the NIH wrote on its website. The agency is soliciting feedback from scientists and the public online through the end of December. Currently, invertebrate animals are not regulated under the Animal Welfare Act in the U.S., nor are they included in national standards for laboratory animals in federally funded studies. Under these rules, scientists must seek approval from their institution's ethics boards for experiments involving animals such as mice and monkeys. These boards ensure that proposed experiments comply with federal laws and minimize pain and distress to the animals. The research must also produce benefits for human or animal health or otherwise advance knowledge. Scientists often use rats, mice, monkeys, worms, and zebrafish as models to mimic aspects of human diseases and study biological processes. But there's growing interest in studying cephalopods to investigate movement, behavior, learning, and nervous system development, which means more researchers than ever are doing experiments on cephalopods. Robin Crook, a leading cephalopod researcher and an assistant professor of biology at San Francisco State University, says studying cephalopods may provide important insight into how the brain works. If we want to understand the fundamental organizing principles of nervous systems, we need to look beyond brains that are all of the same evolutionary kind, and cephalopods are the only independently evolved, really complex brain, she says. Crook authored a study in 2021 showing that octopuses experience the emotional component of pain like mammals do, rather than simply having a reflexive reaction to it. Her experiment involved putting octopuses in a 3-chambered box with different patterned walls. After letting the animals swim freely between the chambers, Crook injected them with a stinging substance called acetic acid and noticed that the octopuses avoided the chamber in which they received the shot. A control group injected with saline showed no such effect. She then gave a painkiller to the octopuses that received the stinging shot and observed that they tended to prefer the chamber in which they got the pain relief. The saline group, meanwhile, didn't show a preference. The results, she concluded, are evidence that octopuses experience a negative emotional state when exposed to pain. The move toward treating cephalopods used in research more humanely started in 1991, when Canada became the first country to adopt protections for them. In 2010, the European Union passed a directive to extend protections already in use for vertebrate lab animals to include cephalopods. Australia, New Zealand, Switzerland, and Norway have also adopted regulations. Last year, after an independent report concluded that cephalopods and crustaceans have the capacity to feel pain and distress, the United Kingdom passed an amendment recognizing them as sentient beings. In the U.S., a group of petitioners led by Harvard University's Animal Law and Policy Clinic sent a letter to the NIH in 2020 asking the agency to amend the definition of animal in its policy on laboratory animal welfare to include cephalopods. The letter made its way to Congress, and last October, 19 lawmakers requested that the U.S. Department of Health and Human Services, which includes the NIH, adopt humane care handling standards for them. In recent years, there has been a wealth of research demonstrating that cephalopods are sensitive, intelligent creatures who, like other animals used in biomedical research, deserve to be treated humanely, they wrote. Jennifer Mather, a professor of psychology at the University of Lethbridge in Canada, also welcomes this action. Mather, who has been studying octopuses for 40 years, was a signatory on the 2020 Harvard letter. As we expand the populations of species that we use for research, we have to also expand our thinking of what matters to them and how we can take care of them, she says. To that end, she says researchers need to think about how to raise and house cephalopods. These animals require shelter or dens, and they need regular enrichment so they can express their normal behavior. And she notes that because many octopuses and squid are cannibalistic, they should be kept in separate tanks. Another consideration is the water quality of their tanks, says Clifton Ragsdale, a professor of neurobiology at the University of Chicago who studies octopuses. Poor water quality can make the animals stressed or even kill them. He thinks the NIH's proposal is very reasonable and welcomes new rules. I'm hopeful these regulations won't be onerous and will improve the quality and kind of research that's done, he says. Franz de Waal, a biologist and primatologist at Emory University, says new regulations could help reduce invasive experiments on cephalopods, such as ones that involve detaching their arms. I think there are going to be questions about, is this really necessary, says de Waal, who also directs the Living Links Center, which studies ethical and policy issues related to animal sentience. I would love for scientists to start thinking in alternative ways. De Waal thinks research guidelines should also extend to other invertebrates, such as crustaceans. He points to a 2013 study in which researchers from the University of Belfast showed that crabs in tanks learned to avoid electric shocks and sought out areas in the tank where they could escape them. The authors argued that this was evidence the crabs experienced some form of pain rather than just a reflex. Basically, every animal that has a brain, I'm going to assume that they are sentient for the moment because the evidence is going in that direction, de Waal says. It's thought that animals without brains, such as starfish, jellyfish, and sea cucumbers, do not feel pain in the same way humans do. Crook is in favor of regulations for cephalopod research, but she says it's not as simple as including them in current policies that apply to vertebrates. Because these are fundamentally different evolutionary branches of animals, it's really hard to know whether a drug that you would give to enhance welfare in a vertebrate animal is all that effective in a cephalopod, she says. For example, the opioid buprenorphine is often given to lab rodents and monkeys as a painkiller. Its effects on cephalopods, however, is unknown. How do you look at a cephalopod and say, that one's in pain and that one's not? Crook asks. There's no point regulating if we have no idea whether or not we're actually enhancing the welfare of the animal. She thinks more research is needed on anesthetics and painkillers to learn how to best carry out experiments that may cause pain to these animals. For now, the NIH is only considering changes, and the agency hasn't yet set a date on when those revisions would be implemented. As scientists learn more about how invertebrates experience pain, research protections may one day extend to much more of the animal kingdom.